there's a small chance that by the end of January I'll actually know your names. And you can contribute to helping me embarrass myself by not knowing your names. If you have something to say, which I hope you will, say your name at the beginning, and eventually maybe it'll help. Unfortunately, remembering names is not one of my strong points. Another thing that's not one of my strong points is programming Java, which may make you wonder why I'm here. Programming in general is one of my strong points, and object-oriented programming I've been doing for a long time. But I'm fairly new to Java, which may make the material a little bit closer to me in terms of understanding what the issues are of learning it. If you have a really obscure Java question, you might be more likely to get a quick answer from David or one of the TAs. But by all means, feel free to ask me. If I don't know the answer, I'm probably as interested as you are in learning the answer, especially if it actually has a practical application and not just something you thought, I know this happens to me, as you look at something and you say, gee, what would happen if I did this? Why don't I go ask the teacher? But by all means, feel free to ask me whatever you want. And if I don't know the answer off the top of my head, be happy to work with you to try to figure out what the answer is. David left me a note up here about what I'm supposed to teach today, which is not exact. I talked to him later, and that's not exactly what we're going to do, but it's close. And in any case, the first thing that I want to do, and I think this is always going to be the first thing, is to find out if there's things that you need, that you have questions on from David's lecture this morning. It probably makes more sense to have a stable base before we start adding new things. And I don't know how much David talked to you about the overall structure of the course. That the basic idea is to spend this week trying to cram your heads full of all the syntax you need to know, and then we can spend the rest of the month having fun trying to get the syntax to actually do something useful. I should also mention hours. I'm normally going to be here from 12 to 5 every day, and recitation will be from 1 to 2:30. Mondays are going to be different. I'm not sure exactly what's going to be happening on Mondays. Hopefully we'll know by Friday in time for me to tell you. But in any case, we'll know. If for some reason Monday comes around and you don't know what time you're supposed to show up here, I'll make sure that at least David and Ganit know that, so you can ask them. I have a 2-year-old kid who's got complicated daycare schedule, so until this month, I've been home with him all day on Mondays. So we've got to figure out exactly what we're doing for a couple hours on Monday so I can come in here. Okay. Any questions about things you've run into or that have run into you so far with this class? Yeah, that's what David said. He was wondering if it was because everything was just completely crystal clear, or if it went over your heads and you have no idea even to answer any questions. Okay. Well, I'll cross my fingers that it's the former and start giving you some more stuff. The first thing I'm going to talk about is arrays. And Java, unfortunately, has only fixed-size arrays. But I'm also not clear where a lot of you are coming from in terms of your previous experience to programming. I know you did the Scheme class, but since I don't know Scheme at all, I'm not sure how much of the stuff that general things that Java has, Scheme also has. I know that Scheme is related to Lisp, and that's about it. So are you guys basically familiar with and comfortable with arrays in the context of other programming languages? No, you're not. Okay.
I'm John. I think it would just be safe to generally assume total ignorance apart from what you explicitly know that we know.
Okay. Okay.
And we'll tell you if that
Okay.
doesn't warrant a decision.
Yeah, if I see everybody sitting there like this, then I'll think, okay. So David talked to you about what are called simple types, integers and characters and other numeric types. And that basically gives you a way of associating a name with a value. And what an array does, it gives you a way of associating a name with a series of values. And there are, as you will learn later, many ways of doing that in Java. The simplest one, the only one that's really built into the language rather than being part of a library, is an array. And just as you would define an ordinary integer, for example, int count, you can define an array where it's the same syntax, but you have brackets and a number following the name of the variable. And this reserves space for 25 integers, which you can subsequently refer to with a similar syntax, such as ages of 1, or you can have a variable here where this is an integer. Oh, good, a question.
Are they having defining age as 25, are they reference 0 to 24 or 1 to 25?
0 to 24.
So the fact that we put a bracket behind ages means that rather than defining an integer, we're defining an array of integers.
Right.
The bracket is what makes it an array. We don't have a keyword array.
Right.
Okay.
One of the nice things about Java being a somewhat interpreted language, in older languages, you define an array, perhaps with a different syntax, 25, and you say something like in Java, you'll get an exception. You'll learn about exceptions later, but basically what it means is your program, it will tell you that your program's not working. If you do this in Java, you'll find out immediately. If you do this in certain older languages, such as Fortran, it will find some other location in memory that you really didn't want to set to 39 and set that to 39. So that's one of the things we've gotten out of 60 years of development of computer languages is that the computer will more likely tell you much earlier in the process that you've made a mistake rather than that you simply get the wrong answer and you have no idea why you got the wrong answer.
And the ages square bracket ID means?
Okay, we have another int ID. So this means we evaluate the value of the integer ID and pick out that element from the array ages. So if we have ID equals 7, or more likely ID is going to be from the middle of a for loop or something like that, then, so if you want to, for example, go through all the elements in your array and do something with them, you can have a for loop. David did for loops with you, right? Okay. you could do something like this. You might have to do something to convert that to a string, so don't worry about whether this exact syntax is going to work in this case. But so this would be an example of going through the array and printing out the values of all the elements. Obviously, in a real program, you're probably going to be doing something more interesting in there.
Read the 4 lines beginning with 4 in English.
For
What are you saying to the computer?
Yeah. Okay, we're saying go through a loop, initialize ID to 0, continue as long as ID is less than 25. Each time through the loop, increment ID. Okay, so now we've defined the loop, and in the loop, we print out the idth entry from the array ages.
So when we call ages brackets, open bracket 1, close bracket, that's going to pull out the value at that array, location 1. Is that what it's doing?
Right.
Okay.
What types can you use for the index of the array? Is it any integer, like bytes, small?
That's exactly the sort of question that I'm not sure of the answer. My guess is that anything that can be interpreted as an integer, you could. One of the things that David wanted me to talk about that I wasn't going to talk about, but since you asked, it sort of makes sense. There's a syntax in Java that lets you turn one type into another type, and it's called casting. And the way it works is you put the type name that you want in parentheses, and then the expression out here. So supposing, let's make a specific example. Supposing that we wanted to use floats, a floating point value as a subscript for ages, and the compiler didn't let us do it. And if it were me and I were writing the program, I'd just try it first and see if the compiler let me do it. And if it didn't, then you can use what's called casting. You put in parentheses the name of the type that you want, followed by the expression that you already have, and then you just use that. So some float is a floating point expression. This is a dangerous kind of thing to do because floats don't always end up being exact, and if the casting to an int is going to truncate it. So if your float is 22.9999999 and you cast it to an int, you'll get 22, even though you really wanted 23. But this could also be a byte or some other accurate integer kind of thing.
Can you cast a char also?
You can. I would think you could cast a char to an int fairly safely. Not something I've experimented with.
For the array, the index values, do those count up from 0?
They count up from 0, yes.
Provide an integer value for your array elements. You can't reference you couldn't say int ages and then in square brackets reference ID or something and then have it be ID elements.
Good question. That gets me to that's the next thing I was going to talk about. Before I answer that, let me see if there's any other questions about what we've already got up on the board.
If we were to reference an array, we've defined that array to only have 25 elements, but if we miswrote our loop and it referenced something outside of that range, is it just going to give us a throw an exception?
Yeah, it's going to throw an exception.
What is this to
I guess it's coming up late on. What does it mean to throw an exception? Does it mean that program crashes? You just say warning? Or?
Okay, I'll give a 1-minute thing just so that David and I can use the terminology in our presentations without baffling you. Basically, when an instruction throws an exception, the Java interpreter will look for another piece of code which has been identified as the piece of code that handles the exception. And so if you're writing a program and you know that an exception is likely, or if the compiler tells you that you have to deal with it, then you can put that piece of code in yourself. There are other kinds of exceptions that, for example, it would be very cumbersome to have to check for an exception every time you use a subscripted variable. So you can check for those kinds of exceptions and errors, but if you don't, it will go to whatever called, if you're in a subroutine or function, it will go to whatever called you, and it will eventually get back to the interpreter if nobody handles it. And then if the error or exception gets all the way back to the interpreter without being handled, then your program will crash. And that applies to any kind of error or exception. And David will, at some point later in the class, talk about the exact syntax for that and how and why you want to do it different ways. So another way to answer it, unless you do something special about it, it will crash your program. Okay? So this is the static way of defining an array, where you say int ages, and this can be any type. It doesn't. I was just using ints as an example. It could be a float. It could be a char. As you learn later about other types and classes, it could be any of those. If it's something you make up yourself, they all work the same.
Can it be mixed?
Everything in an array has to be the same kind of thing. If some of them are going to be ints and some of them are going to be floats, you can just make them all floats and turn the ints into floats. And later on, when you learn about classes, you will find that everything is an object. So if you really have a basket of completely unrelated things, you can make your array of objects, and then you just have to know what they are so that you do appropriate things with them. Okay. You can also write int you can define an array like this, and that just says, I'm going to have this array of ages, and I don't know yet how big it's going to be. And then later on, you can write, and I'm glad I brought the book because I don't remember this exact syntax, because I haven't done anything with arrays other than sort of read about them. So I'm going to look in the book. Probably around page 96. Does make sense now that I look in the book. So the way I was thinking of didn't make sense. You're going to learn a lot about the new operator over the course of this week. What it does is it creates something. And in this case, what it's doing is it's creating a 25-element integer array. So we say new int of 25. So we have the array, and then we assign it to ages. Ages has already been defined as an integer array. So now we actually have the actual array that's 25 elements and assign it to ages. So these two statements together perform the same function as this one. But this gives you more flexibility because here we could have a variable such as class size. So if you don't know at the time you do the declaration how big the array is going to be, you can use this syntax. And whichever way you define it, it works the same from then on.
If we tried to define ages twice, if we maybe made a mistake, or maybe
And then, okay, suppose
we're going to throw it away.
so suppose you said later ages equals new into 40. Okay. An array is a type of object in Java. And there's a lot of other kinds of objects that you're going to learn about probably tomorrow. And let's contrast this with something like foo equals 7, foo equals 13. It's the same kind of thing. Foo is equal to 7 until you get to the second line, at which point it's equal to 13. So here, ages is set equal to this empty 25-element array of integers. And it continues to be this empty 25-element array of integers until down here you say create a 40-element empty array and assign that to ages. So ages is now a 40-element empty array. And anything you've done to ages in there goes poof, because you're assigning a new thing en masse to ages.
And that eventually gets garbage collected.
Yeah. On Tuesdays, except when Monday's a holiday, in which case it's on Wednesday, at least in my neighborhood.
So would it be allowed to say end ages 25?
Well,
So instead of the ages equal new end, would it be allowed there to just say end ages square bracket 20?
no, this is a declaration where you're saying ages is an array, and it doesn't actually do anything. It just lets the compiler know so that it can check your program. And here is where we actually create. So if you've got an array that you're going to be doing things like this with, then you should define it like this. If you've got an array, for example, if it's days of the week and you know there's going to be 7, there's always going to be 7, then you would define it this way.
Can you do that in one line? Just the end ages bracket equals?
Yeah, this would be a line by itself.
Can you combine that with the second line?
That's basically what this is. Is these two combined?
Oh.
So you can't use a variable in that form?
I'm not sure. I don't think so.
I don't think you can.
Yeah, okay.
If it's anything like C, I don't think you can.
Yeah. It's a lot like C. What catches you if you know C is when it's not like C. And if you don't know C, then you're lucky, because you won't get misled by the ways in which it's different, nor helped by the ways in which it's the same. Now, one other thing that I mentioned about this being an object, let's come over here and erase some more of what David put up. And then we wrote more ages equals ages, assuming that more ages was declared appropriately. What this does, it doesn't create a second 25-element array. It creates, I was supposed to say about references first. Okay, let me take a step back. There are basically two kinds of things in Java. There are basic types, ints, floats, chars, and there are objects, which is everything else. And when objects sort of exist someplace, And when you have a set of variable equal to an object, and an array is a kind of object because it's not a basic type, what it acts like is a reference to the object. So it's not, you have an object out here, and the variable basically says this is where the object is. So when you say more ages equals ages, you now have two references to this 25-element integer array. It's one array, and you have two references to it. So, for example, we say more ages equals ages, and we say ages of 7 equals 25, and then we say, I'm going to probably do this a lot. I'm going to say print line. It means system.out.println, but I'm just going to say typing or writing, whatever. Print line more ages of 7. This will give you 25, because more ages and ages are referring to the same region of memory, the region of memory that contains this object.
Why would you need two names for the same object?
Well, I'm not going to get into that right now. One example could be if you're calling a function, and so the name of the name inside the function is the same as the name outside the function, or something like that. But don't worry too much about why you would do it now, because it's hard to give good examples without getting into a lot of other underpinnings.
So suppose you really wanted to create a new array?
Yeah, then you could say more ages equals new int of 25. And that would create yet another 25-element array.
But suppose you didn't really know what this existing array was. Suppose you want to make it similar, but you didn't know what it is.
You can, I'm not sure exactly what the name of the method is. I think it's probably size, because that's what it is on some other ones. So you could say more ages equals new int and don't worry too much about understanding this or whether I got the name right, but basically what this says is figure out what the size of the ages array is, and then create a new array that's the same size. I think I have the size right. And
Is it length? Is that the same as size?
length is for strings. And I know that vectors use size, and so I'm going to guess that arrays use size also.
It would kind of be the same as length in a list.
I think it's length.
You think it's length? Okay, well, it's easy to find out for sure in either case. So this gives us a second 25-element array that's really different, but it's the same size. So if we did this, created this 25-element array, and then said more ages equals ages, and then said ages equals a 40-element array, we now have split it apart. We now have ages as this new 40-element array, and more ages is the older 25-element array. Now they're completely separate from each other, and changes made to one don't affect the other one.
Of course, we'd also have to copy the values over if we wanted.
If you've created them as two separate arrays and then you wanted them to be the same, you would then have to copy them. Okay. Any other questions about this messier array stuff?
So far, this seems to be what we've seen in schema as a list, rather than, I was imagining an array would be, for example, two sets of twinned values, like one would be an integer for age and the other would be the name of the person whose age it is, and so on. Do you see what I mean? Yes.
Well, you can have an array of anything, and one of the kinds of things you can have array of is an array of arrays. If you were keeping track of names and ages, then you'd probably have an object that for each person that contained their name and their age, and you have an array of that kind of object. But we don't know about objects yet, so I'm not going to show it to you. This is why we're trying to get everything into you in a short period of time, because it all interrelates. And once you learn about objects, a lot of these other things that were array is sort of a special case of an object that I'm teaching you about now, and a lot of this stuff becomes clearer once you understand the general case of objects. Did David talk about initializers? Well, maybe, okay. When you declare something, you can give it a value. I meant this kind of initializer.
He did it and said it was a good idea, but we don't really know much about why.
Okay, you can do the same thing with arrays. For example, you can say int ages of 25 equals you can do this, which creates a 25 element array and initializes the elements to the values contained within the braces.
Did you have a shortcut? Because suppose you wanted like 0 to 24 inside, no, like a range of numbers. Do you have this double dot notation?
Not here, no.
Yeah.
If you wanted to do something like that, you'd have to actually write a loop to put the numbers in. Now, suppose you have this list, and it changes a lot, and you're not sure how many numbers are in it. You don't want to have to keep counting and changing it every time. You can leave this out. You can say int ages brackets equals, and then the list of values. And the compiler will count for you and create an array of the right size. Question?
Why would you ever put in the number? That just seems like...
Well, it depends on what kind of an array it is. If it's a situation where you know how many elements there are going to be at the time you're writing the program, for example, an array of strings for the names of the days of the week, you know there's going to be 7 elements. You might not, depending on the you might fill in the names later on once you know what language you're operating in, so you don't want to have an initializer. But you know there's going to be 7 elements.
So now if you do put the number in the brackets there, suppose that number doesn't match with the numbers that you're initializing. If it was longer, would it just put zeros at the end? Or would it give you an error?
I don't know that. There's 2 different cases. If you put in too many values or too few values. If you put in too few values, it would probably fill them in with zeros, because if you don't put in anything, it fills them in with zeros. But I'm not sure of that, and I'm not sure what would happen if you put in too many values. I would recommend, if you've got enough numbers there that you're not sure you've got the right number here, just leave it out.
So that's not something, I mean, I'm thinking that maybe you don't have the values yet for all of them. That might be the case when you would put in a number. Say you know that you have 30 different ages,
but you only know
20 of them
right.
so far, so you would initialize those 20 and leave the other 10 blank. That's not something that's commonly done?
Not in my experience. And that includes experience in other contexts and not just Java. I would probably do it differently than that. Like create an array with no number and then copy it or something like that, so it was clearer what I was doing. Or at a minimum, put in a. Did David talk to you about comments?
Yeah.
Okay, good. Always a good thing if you get to it. Okay. Any other questions about arrays? Okay. And let's see. Let's leave this up.
I mentioned at the end of the lecture this morning, so a vague idea, but they just break and continue.
Yeah, he said he talked to. I don't remember what he said. Why don't you? Does somebody want to tell me what he said briefly about break and continue, so I can?
Basically, only can be inside a loop. That's it.
Just break shit out of the loop and stretch it, and continue increments the pointer and goes back.
Okay, so he talked about them in the context of for loops, and you can also use break and continue in a while. He talked about while loops. You can also use break and continue in a while loop.
Can you repeat the things before? Could you repeat like?
Okay, sure.
For example, before.
Let's see. This would normally be on 2 lines, but I don't have 2 lines on the blackboard. So this says if ages of id is less than 0, continue. So basically we're going through the loop and printing out all the ages except those which are less than 0, which are obviously errors. Maybe we decide to use an age of -1 to indicate that we didn't know it yet, so we're not going to print it out. Not that that's necessarily the best way to do that, but supposing we had. So if ages is less than 0, continue. That's an example of a continue in a for loop. Alternatively, we might have said if ages is less than 0, break. If we know that it's an example like what you had said, where you'd initialize part of the array and then put -1s at the end, then we know that as soon as we get to the first -1, we're done. And we could say if ages of id is less than 0, break. And that'll get us out of the loop as soon as we get to the first -1. Break and continue, especially break, are probably more useful in the context of a while loop. Because with a for loop, usually you know how many times you want to go through it, and you're going to go through it that many times no matter what happens, unless somebody pulls the plug on the computer. With a while loop, usually you want to go through the loop until something happens. And it could be that there's a lot of different things that could happen in the context of a loop. One syntax that I have often found useful is the forever loop, which begins while true. And that basically says to the compiler, go through this loop forever. And given that you probably actually want to get a result back from your program at some point, you're going to have one or more if statements in the middle here, if something or other break. And this is there are some functions, methods, whatever, in Java that do something and return a result telling whether they succeeded. And depending on the structure of your program, it could be unwieldy to actually put that whole thing into your while loop. So you might supposing you have okay, so this says forever, do some stuff, call this method getLine. And did David talk about exclamation point as not? Okay, so getLine is a imaginary, a made-up method that you have off someplace that gets a line from somewhere. And if there's no more, it returns true if it succeeded in getting a line, and it returns false if it wasn't able to get a line.
I think he said it should be like the hat thing if it's a Boolean, or not.
Caret?
Yeah.
Oh. Okay, I've been using that and it works. That's what I get for not taking a class and just trying to do things that work. I can put in one of those too. Okay, I'm going to change the definition of getLine to avoid this problem. GetLine is a function that returns false if it actually got a line, that returns true if it failed to get a line.
Well, it didn't get line.
So if it returns true, then we didn't get a line, and we want to break out of the loop. Otherwise, we do more stuff. And there might be other cases down here. We might also say that if the line that we got doesn't have any characters in it, we want to do a continue because we don't want to process the line if it's blank. I'm not going to write any syntax for that because that gets into too many other things. But that would be a case of using a break and a continue in a while loop. Did
You mentioned that there were labels for break.
yeah, I'll talk about that. The something else which comes first, which is nested loops and break and continue in nested loops. A break or a continue only applies to the innermost loop that you're in. So, for example, if we have if we do a break here, it will break us out of the while loop, but not out of the for loop. And if we have, and similarly, if we have a continue here, it will continue to the next iteration of the while loop. We could have a breakdown here if bad news break. That's outside the scope of the while loop and inside the for loop. So this would break us out of the for loop. And I'm going to try to use some good style here. Recommendation, if you have a long block, nested braces, put a comment next to the closing brace indicating what it is that you're closing. It makes it a lot easier to understand what's going on in a program, especially as you get multiply nested in And you see this brace, and you're saying, okay, what's that the end of? And you're scrolling back up to try to find out what it was. So this break gets us out of the for loop. This break gets us out of the while loop down to here, where we would then for through this thing again. Now, sometimes you have a situation where you have multiple nesting, and something really bad happens in the innermost loop, and you want to get completely out to the outside. That's a case where you could use a named break. So we have some name up here. Let's call it shy. And if really bad, break shy. So this name matches this name. So notice there's a colon after the name up here, shy. So this will get us out of all the loops back to and including the loop that has the label shy on it.
The label can either be before or after the break. We want to break to shy, but does shy have to be before?
Yeah, shy is a label that identifies.
Lower down in the code.
A label identifies, unlike go-to statements, which you may have heard rumors about in some less structured languages, this does not identify a line that you go to. It identifies a loop that you break out of. So it's identifying this for loop. There are ways to abuse named breaks to get them to function like go-tos in some circumstances, but pretend they don't exist. So
in the assembly code that we did last month, we did branches that look kind of like what this is, but it sounds like this is not at all.
Yeah, in assembler where you don't have the highlight, you have to use go-tos and branches or whatever they're called in a particular assembler because you don't have built-in things like this. So this is basically just to get you out of a loop. And it's the loop that's labeled. So in a language with a go-to or a branch, whether it be Fortran or assembler, you would say go to shy and would go to here, but the break doesn't go to here, it goes to here. It breaks you. This is identifying a loop, and the break is saying break out of the loop identified by this label.
And that index variable I would be just where it is.
Right.
When the break has the value.
Right. Although one thing that one does sometimes in Java is you declare the loop variable here. The only reason we have this variable I is to loop through this number of times. It's not something that has meaning outside the context of the loop. So we can define, you can say int I equals 0, which is just like we had here, int count equals 25. It defines an integer I and initializes it to 0. And did David talk about scope of variables at all?
A little bit.
A little bit. Okay, I'll talk about it a little bit more. Since we've defined this int in the for loop, its scope is only as long as the for loop. So if we did that, and then we tried to use I down here, it would be a compiler error because the compiler no longer knows about the variable I because I only exists in the for loop. If you had if you didn't have this and you had the variable I defined outside it, then we would know about it here, and it would have whatever value it had when we broke out of the loop. So if there were a context where you wanted to know what I was when you broke out of the loop, it would be important to declare I so that it had scope through the whole script and not just inside the for loop.
Now, if you had an I outside the for loop and you also did this,
Then you would not get a good grade on your project.
okay.
But yeah, you can do that, and it will work.
Okay.
So that basically, when you do this, it forgets about the I that has the other scope, and you have this. So if you have I equals 15 up here, and then you break out of the loop when I is equal to 3, then when you get back down here, I will be 15 again. It's not that the value of I has changed as much as you have two different variables, and they both happen to be called I. Me, but if you go home and watch Password, Alan means Alan Ludden. If you watch Candid Camera, anyway. Okay. Any other questions about break and continue, whether they be syntactical or motivation or whatever? Unfortunately, it's hard to get. Sometimes it's hard to get the motivation without knowing more stuff and having a project, but you can't get a project until you have all the syntax. So you just try to remember enough of it to get through.
Continue works the same way as break does with labels?
I believe so.
You can continue to the other one?
Yeah, it would make sense to be able to do that.
It seems like you said that continue keeps you within the same loop. It just skips all the rest of the...
Right, but it would make sense to be able to...
So we want to continue out of that loop.
Well,
stay within it.
Yeah, I'm not sure. What you would want to do is be able to have a continue that gets in here, that gets you out of the while loop and out of the rest of that iteration of the for loop and continues with the next for loop. And
But would that be any different than a break?
yeah, because a break would get you. Okay, let's put some more code in here. Print line I. Okay, so if we have in here just an ordinary continue, an ordinary break, it'll get us out of the while loop and do print line I and do this if. If we had a named continue, which I'm not sure we can do, but just in terms of what the difference is, if we had a named continue, then it would get us out of the while loop and the rest of this for loop iteration and continue back up here with I getting testing I and checking and incrementing it. But I'm not sure that the syntax supports that. And if you ever discover that you need to do it, then we can find out.
He said something this morning, I'm not sure I understood what he meant. He said the syntax favors iteration rather than recursion. Does that mean anything?
Okay, he talked about he did the recursive factorial. That was what was down in Scheme. The recursive way is the natural way to do a factorial. In Java, the natural way to do a factorial would be to write a loop and just go through the loop and multiply by the various numbers within the loop.
Okay, because we have this for and while or whatever, that's why it's natural to think of it.
Yeah.
Okay.
And it just so as you get more experience, you would think it would look funny to do it that way in Java, but it would work. Okay. Any? Okay, where are we on time? Let me ask you this. There is one other thing we have up here. Let me see if I have any. One other thing I'm supposed to tell you. you got Java installed on your machines, or if you don't all have it yet, hopefully you'll have it by the time you get back there after Richard Stallman's talk. And apparently the installation didn't change your path, and you need to change your path to include some additional directories. And I was not told that information about exactly which directories, so make sure you check. Java's not going to work until you do that, so check with your TA about what to do.
Did you change the path? Do you know what the path is? Do you remember it offhand? Did we just write it up?
It's used,
It's written on the whiteboard, right, Jeffrey?
yeah, but it's kind of scrawled in illegible because the
Okay.
markers don't work. What you need to do is you need to go into the .dash profile. And this is in your home directory. You can use VI or Emacs or whatever you feel like. And there should be one line that sets the path variable, and it looks like this. So what you want to add right here. You can, okay. So you add a colon, and then it's user, Java, JDK 1.3.
Is that a colon? Sorry.
It's a colon. Yes,
But also above path.
yeah, this is already there. This is already there. So you look for this line, add this in, log out, log back in, and everything is happy.
Excellent, thank you.
All right, so I can either talk about the switch statement, which is more syntax, or Shai was warning about the dangers of trying to pump too much stuff into people's heads in one day, and I know you had a lot this morning. If you don't want to learn about switch right now, we can learn about that some other time, and we can try to be a little less information intense for the next half hour. It's up to you folks. Should I go for it?
Yeah, sure.
Okay.
So we'll get the syntax over with.
Okay. Before I do this, we were wondering about whether you can have a name continue as well as a named break.
I don't think it makes sense to have a name continue. You have to name the loop, right?
Yeah. It seemed to me that it did make sense, but although I didn't have any particular real-world examples in mind, I could sort of think of a syntactical example. Okay. A switch statement is sort of like a simplified if, else if, else if, else if. It's not a good way to start. Suppose you have some variable, and it has to be a simple type like an integer or a character, and you want to do any of several different things based on the value it has. You could write, for example, if I equals 0, do stuff, else if I equals 1, etc. And a switch statement is basically an alternative way of doing something like this, where all of your tests are on the same variable and you're testing against a collection of constants. And you would write here switch I case 0. Let's put else if to match else. So these two syntaxes are functionally equivalent. We check whether I is equal to 0, do something, check if it's 1, do something else. If it's not 0 or 1, we do a third thing.
If you omit the breaks, does it do the case and then also do the default and not do the
Yes. That's what the break does. A switch is like the inside of a while loop. It goes through from wherever you are till the end unless you get out of it. And so you use the breaks to get out of it. And if you leave them out, it falls through. And there are, at least I've run into once in my experience, situations where you actually want to use that behavior and you want to have it fall through from one to the other. But I've also used languages that function differently, where you basically, once you get to the next case, it automatically breaks out, and that seems to me a lot easier because 99% of the time there is going to be a break here, and it's an error, a logic error if you leave it out. I think they're trying. The only reason I can think of why Java requires the breaks is that they're trying to be consistent with C, which works the same way, but they didn't have to be consistent with C. And if anybody comes up with any other good reason why they did it this way, I'd love to hear about it. So this can only be used for a simple type, for an integer or a character or a byte. I think you could use it for a float, but I don't think you'd want to. Because this is the same with, I was talking about before with casting a float to an int. It's checking for an exact match, and floats don't match exactly, unless you're lucky. Also, I think in Java you end up finding that you don't use the switch statement very much because of other object-oriented features that you have in Java often lead you to better ways of doing them than switch statements that you might be more likely to use in C. But it's here if you want to use it.
And the cases don't have to be directly sequential. I mean, for example, if the original if we wanted to do was if
Right.
I equals 37,
Right.
else if I equals negative 12,
Right. They
it
could.
would be case 37 stuff break, case
Right.
17.
Right. They could be anything in any order. And if you do use it, you might end up finding that what makes sense is for these not to be explicitly written as numbers. They might be constants that are defined someplace that have a specific meaning. Usually something like this isn't actually going to make a lot of sense. Why are you doing something when this is 0 and something else when this is 1? Maybe they're days of the week and you want to do something different for days of the week. And so this is Sunday or something like that. And I'm, again, not going to get into the syntax for this right now, but you can, there's a way to say case Sunday, case Monday, etc. And that makes your code easier to read.
I may have missed this, but presumably, could those cases be overlapping so that a particular instance might have more than one of the case conditions apply to it?
That's not possible because you're looking at the value of a specific variable, and the value has exactly one value at any particular time. It's either 0 or 1 or something else. You don't get to put conditions here. It's a value.
Right.
If you have anything more complicated than an exact match to a specific value, then you would have to use an if statement.
So if we didn't have the break after the case 0, supposing we had the one after the case 1, for example, but
Yeah.
it's not after the case 0, is it going to get to the case 1 and say, oh, well, I is not equal to 1, so I don't do stuff?
No,
It
it
will
will
still
do
do
this stuff, and then it will also do this stuff, and then it would break.
Okay. So it doesn't do any comparing? Or does?
So it doesn't check.
No, basically this is a label. If you consider this as a label, and what the switch does is it jumps to the right label, and then in the middle of the block, and then continues through the block until it has some reason to leave.
Do you not need curly braces to delimit the things inside there?
Right. Right. You don't have curly. There are no braces in here. This is not a block, so which is why it falls through.
Can you arbitrarily nest curly braces, or can only one set of curly braces go with the statement?
Basically, the way it works is that things such as for and while and if are followed by statements. And a statement is either a simple statement such as I equals 13, or it's an open brace followed by a series of statements followed by a closing brace. So if you have a situation where you have an if and only one thing following it, you don't need the braces. Sometimes it's good to put them there anyway to make it clearer what's going on. In theory, you could put an open brace and some statements and a closing brace, even if you didn't need to, and that would be a statement. One other thing about the braces is with regard to scope is, like up here we had the int on the for, is if you have a matching pair of braces and you declare a variable inside the braces, then its scope would just be those braces. I'm not sure if I've answered your question, but okay. Any other questions on switch or on any other things that you realize now that you have a question that you didn't have before? Yeah.
I'm just interested, what other object-oriented environments, you mentioned you've been involved in them a lot, but Java not very much. What are the other object-oriented environments?
There's a lot. The one that I've been working in is PowerBuilder, which is a proprietary, which is to say not standard, software development environment, which is very much oriented towards database manipulation and towards display of windows. So that's the one that I have experience with primarily. I've also done a little bit with Visual Basic, and there's also, in addition to those which I've used, there's also C++, which is one of the major ones that's used now, and there's Smalltalk, which is one of the original ones when they were first developing ideas for object-oriented programming, but I don't know anything about it at all. And there's JavaScript, which is similar to Java, but not the same, but is also object-oriented. Any other questions? Any other answers?
I noticed a couple times we've seen where there will be something dot something. For example, I think you did ages dot size or something like that.
Yeah.
And that's kind of confusing to me. I know it's probably something we'll see later on, but is there
something
you can briefly say?
Yeah, I mean, given that given that we have time and there doesn't seem to be anything more pressing, I'll talk about that a little bit. When you this relates back a little bit to scoping. If you have an ordinary script and you define your variables I and count and ages and all that stuff like that, and they have they're the scope within your script and you don't have to say anything with a dot to refer to them. If you have something that's, if you have an object off someplace and the object has functions which are called methods, and the object can also have its own variables that are part of the object and not part of your script, you can refer to the methods and values on that object by putting the name of the object and then the dot and then the name of the function. Or usually you don't refer to values on other objects. That's generally not good practice. You generally only refer to functions on the objects and let the objects worry about their own variables. So when I said ages.size, that meant ages is an object, it's an array object, and arrays have the definition of the class array includes a function called size, which returns its own size. So we're saying, okay, find the class of arrays and find the function size in that class and execute the script associated with that function and return the value, and it applies to itself. So the function would be ages applying the function size to itself and giving you back the answer.
And if you've got multiple dots, it seems like we saw one where it had something and then dot and then something and then another dot.
Okay.
Is that the same concept or is it something?
Yeah, in that case, out, I believe, is a property or a variable on the object. System is an object, and one of its variables is called out, and out is also an object. And out contains the function. Out is a member of some class. I don't know what class. And that class has a function called println. So we're calling the function println on the class represented by system.out. Sometimes you end up calling a function on an object, and that function returns an object, and you call another function on that one. And you get used to it.
Is there not a magic thing associated with the...
I remember whether it was size or length. I remembered that vector was size, but there were some other people who thought it was length. Yeah.
Size gives you the number of elements in it, and length gives you the total array. So if you want to count how many elements are there in the array, you may have a length of 100 with only 20 elements.
Okay.
You can pick up the size or you can pick up the length.
Thanks.
I think.
Okay, well, the important thing right now isn't the exact name. It's good to know that but looks like we have some research going on in the back corner of the room. It's a magic thing, but it looks like a method.
Well, it looks like a property, right?
Looks like,
No,
oh, it looks like a property?
yeah, it looks like a property.
So
It's just variable.length.
variable.length, okay.
So it's inconveniently different than vector.
In two ways. Okay. Okay, I guess we're done.